Hi everyone, this is Mr. Kieran, and in this video, I'm going to be looking at the octet rule and the formation of ions. So what I have here is a picture of a neon sign. And the reason I chose the neon sign is because neon is a member of the noble gas family. And we know that the noble gases are very chemically inert. In other words, they don't like to react with other elements. Well, what is it? Well, the reason is because of the electron configuration of these elements. When you look at all of these atoms or the elements, you look at the electrons, you'll notice that the electrons are situated such that the outer energy level is full. So here we've got helium, just as an example, and it has 2 electrons in the first energy level, and that's all it can handle. So this energy level is full, so we've got a full valence shell, we say. Now you look at neon, neon's very similar. It has 8 electrons in the outer level. Well, this level can only handle 8. So it's considered full. And the same thing is true with argon, and it'd be krypton, xenon. So there's something special about having a full outer energy level. It makes the atom very stable chemically and such that it doesn't want to react. So that means that if the noble gases are chemically inert, all the other elements are going to react. And what they do is they try to react such that they have a full outer energy level. So sometimes what happens is some of these elements will be losing electrons. For example, on this side of the periodic table, they might be gaining electrons, or they might even be sharing electrons. There's 3 ways we can do that. So we're going to be looking at the gain and loss of electrons to form these stable full outer energy levels. So let's look at an example. So here we have fluorine. So fluorine has 9 protons, 10 neutrons in the nucleus typically, and because it's got 9 protons in a neutral atom, we're also going to have 9 electrons. And these 9 electrons are located through the energy levels. So you got 2 in the first energy level and the remaining 7 on the outer energy level, the second one. But we're not stable. We do not have a full energy level. So what tends to happen is that the fluorine will want to pick up an extra electron. And as it does so, it's going to become charged. So the nucleus doesn't change. We still have 9 positive protons and 10 neutrons. However, because we've added an electron here, we have 10 electrons now. And as a result, this atom has an overall charge of -1. So we call a charged atom an ion. And because this ion has a negative charge, we call it an anion. Anion. The way we remember it has 2 N's, so negative. That's how we remember. Now to indicate that this atom is an ion now, what you have to do is you have to put square brackets around it and indicate the charge. So because we picked up 1 extra electron, we have an extra charge of 1 negative. There we go. So you can draw a Bohr-Rutherford diagram to show the common ion. That's what we call this for fluorine. So we have having a charge of -1. Same thing's true if you draw the Lewis diagram. So the Lewis diagram, you add the extra electron. So I've drawn it in red here. And because you have added the extra electron, we put a negative in square brackets around the Lewis diagram to indicate that this is an ion, an anion. Well, let's look at the opposite situation here. What happens if we have something like magnesium? So magnesium has 12 protons, 12 neutrons, and 12 electrons when it is neutral. So it has no overall charge. And the 12 electrons are situated such that the first 10 electrons are in the inner energy levels, and we've got 2 electrons, 2 valence electrons in the outermost energy level here. Well, here's the thing. We want to have a full outer level. So what we can do, there's 2 options. We can pick up 1, 2, 3, 4, 5, 6 extra electrons, which is quite a bit of work. It'll be quite challenging. Or the easiest thing to do would be just to lose 2 electrons. So if 2 electrons are removed, you end up with a full outer energy level. It's not the same energy levels before, it's 1 lower, but nonetheless, this energy level is full. Now to indicate this, we're going to look at the nucleus. We've got 12 protons. That hasn't changed. 12 neutrons. But remember, we lost 2 electrons. We only have 10 electrons now, so 10 negative charges. So we have an overall charge of positive 2, 2 plus. So what we do, we put square brackets around this atom to indicate it's now an ion, and we show the charge up here. You always put the number first and then the positive, so 2 positive. So this shows you that this is an ion now with a charge of 2 plus. Because it has a positive charge, we call this a cation. And the way to remember the cation is the T looks like a plus sign, so positive ions here. Now, when you look at the Lewis diagram, very, very similar. What happens is these 2 electrons are going to be removed, or they lost, and we end up with no electrons in the original outer energy level, so we don't have any here. And we put in the 2 plus charge there. So in both cases, even though we did opposite things, both of these atoms end up as ions that have a full outer energy level, and that makes them very stable now chemically. So when we look at the periodic table, if you look at the number of valence electrons, let's look at chlorine here and fluorine. They have 7 already electrons in the outer level. So all they need to do is gain 1 extra electron here. So you gain 1 electron. And when you're gaining this 1 electron, you form an anion, a negative ion with a charge of -1. Now sulfur, it's almost there. It has 6 electrons in the outer energy level. So does oxygen. So both of them are going to gain 2 electrons. And as a result, they're going to form anions, but these are going to have a charge of 2 negative. Nitrogen, phosphorus, both have 5 outer electrons. So what happens here, they can pick up 3 electrons. 1, 2, 3. And as a result, they tend to form ions that have a charge of 3 negative. You get the idea here. Well, let's look at the other side of things here. Let's look at the alkali metals, the first group. So all of these have 1 electron in the outer energy level. So what they tend to do is they tend to lose that. It's much easier for them to lose the electrons than to gain. And as a result, they end up with an overall charge of 1 plus. So these are now cations. You don't need to put the number 1 there. I'm just putting it there just to compare with the other ions. Now beryllium and magnesium, both of these, it's easier for them to lose 2 electrons, so they form cations with a charge of 2 plus. Boron, aluminum, they have 3 electrons in the outer level, so they're going to lose those 3 electrons. It's easier for them to lose 3 than to gain 5, so they form cations with a charge of 3 plus. How about carbon? Well, carbon and silicon, they've got 4 outer electrons, so they can do one of 2 things. They can pick up 1, 2, 3, 4 electrons, so form an anion with a charge of 4 negative, or just as easily, they can lose 4 electrons and form a cation with a charge of 4 positive. So they can go either way because they're exactly halfway. It's just as easy for them to lose than it is for them to gain. So let's recap. So far, the group 1 can form ions with a charge of 1 plus. Group 2, cations, 2 plus. Group 3, cations with a charge of 3 plus. Group 14, they can form 4 plus or negative. It depends what they're associated with, how they're reacting. Phosphorus is going to lose the 3, so anions, 3 negative charge. Sulfur group and oxygen group 16, 2 negative, 1 negative. And remember, the noble gases are stable. They do not change the number of electrons, so stable electrons. And that's summarized over here in this chart as well. Another way you can look at this is also by doing Lewis diagrams. It works exactly the same way. So if I look at, for example, fluorine, fluorine would like to gain 1 electron, it has 7 outer electrons. Let me just put them in red here, sorry. So does chlorine. So group 17 just needs to gain one extra electron, so they form anions with a charge of 1 negative. Oxygen, sulfur, and the rest of group 6, they tend to gain 2 electrons, so they end up with a 2 negative charge. Nitrogen picks up 3 electrons, so 3 negative. Same with phosphorus. 1, 2, 3 electrons it picks up. Now remember, carbon can gain, or in group 14 can gain or lose. So some of them will gain 4 electrons, so form 4 negative, and some of them will lose 4 electrons and have a charge of 4 positive. So again, these are plus or minus 4. Now boron, aluminum, it's easier for them to lose electrons than it is for them to gain the 5 electrons. So they lose 3 electrons, give them an overall 3 plus charge, so they're cations. Beryllium and the remaining group 2 are going to lose 2 electrons, so they're going to form cations with a charge of 2 plus. And finally, group 1 and hydrogen lose the single electron, so all of these are going to have a charge of 1 positive, or just plus 1, like so. There we go. So to summarize, you can look at all of the elements outside of the noble gases wanting to gain or lose electrons such that they have a full outer level. The elements in groups 15, 16, 17, they're going to gain electrons and form anions. 1, 2, 13, they tend to lose electrons and form cations. And remember, in between here, we've got the group 14, they can gain or lose. It depends what they're reacting with. And finally, remember the noble gases, there's no change in the electrons. They're already stable. And that's it. So hopefully you remember this from grade 9 and 10. And we're going to be applying this when we're talking about bonding in the next couple of days. Take care.